Hey guys, it's IDW, and today, as this glorious sun rises of Minecraft, we are going to be discussing something called random access memory. So that begs the question, what exactly is random access memory? And, as the name implies, it's memory that you can access at random, in any order. So, as far as writing memory, that's a really important distinguishing fact that sort of separates random access memory out from stacks and such. So, yeah. Basically, what random access memory is it's basically a combination of every single last feature that you could possibly want in memory. It's something that you can write to whenever you want to, read from whenever you want to, and yeah. Unlike read-only memory right here, which can only read when we tell it to, and we can't write to it while the computer is running. We could just like break the torches while the computer was off and replace them with new numbers, but that really isn't going to work with random access memory. Random access memory is the thing that the computer can edit on its own really, really, really easily. So, if that hasn't really jogged your memory, I'd like you to sort of think about it like it's a Word document. So, you have three different inputs. You have what you type into your computer, you have when you tell your computer to save the information, and you have and you can tell your computer to print it out on like a sheet of paper so that you can read it somewhere else. So if we were typing a word, basically, in this episode, we're going to be doing this with redstone, something that's going to be able to have data that comes in, and then we're going to have the option to write it to the memory, and then we're going to have the option to read it back out. So this is going to require all the components that we talked about in the first video, as well as this right here, which is a decoder. So yeah, so let's just immediately jump into it. Actually, we won't be using the repeater lock yet, but yeah. So we're going to be starting off with our RSNOR latch. If you remember, that's the thing that can be set and it can be reset. So if we have our two wires coming out like this, then if I was to flip this lever, then it would flip the latch's state so that only this wire was on and the other wire was off. And if we flipped that, then it would switch the state again. And it will hold this state forever until we flip the other lever. So, yeah. So now we're going to have to make it so that, first of all, we can read only when we want it to. And also, we actually are going to want to have our data come in one wire. So we're going to have one state of this thing be when it's on, when we want our output to be on, and one state when we want it to be off. And we're going to have both of those states come from this one wire. Now, if you think about this for a second, this is sort of the purpose of a decoder over here. So what we're going to do is we're going to make a 2-bit decoder for this thing, basically. So what that means is that whenever this wire is off, then we want it to switch to this state. But whenever it's on, we want to switch it to this state. So yeah. But the thing about this right here is that we can't actually tell it that we want to write at a specific time. We're going to have to say that both of the states need to be off, except when we want them to be on. So yeah, the way that we do that is with an AND gate, and I've been over this in multiple series, but just because you might be new, if you use an AND gate, then that's sort of like something that enables you to let something through. So I'm actually going to build something that uses some AND gates, and then I'll sort of show off exactly how the AND gates are actually useful to write this thing. So yeah, see you guys in a second, where I'm going to be adding AND gates onto this thing. And we're back. So I've just sort of added on an AND gate right here. I actually took off the inverter on this bit, because you need to invert the inputs into an AND gate, you would have resulted in a double inversion. And by the way, if you're new, once again, if you plug a NOT gate into a NOT gate, then you're going to get the same thing as you're sending into it, so there's sort of no purpose. So when I made the AND gates for this thing, what I basically had was, since one of them was I used the invert of the input, basically this is what I have, so there's a double inversion right here. So all I did was I just did that, and technically it can't flow in this direction, so yeah. So here's the AND gate right here. I just made it so that it powers both of these torches. So yeah, this right here is mostly our random access memory cell done. This is actually what is called a gated data latch. It's generally referred to as a D flip-flop, though, even though it's technically not one. That's not something for this series, but yeah, thought I might as well throw that out there. But there's one last thing that we need to make this in order for it to be random access memory, and that's an option to read only when we want, say that we want to read right now. So I'll just add another sort of wire coming like this. That's going to be our read wire. So whenever we flip this wire, lever on, then it's going to actually read out the data that we have saved in it. Actually, it's going to read out the inverse. Now that I think of it, a better way to do it would be like that. Just because we actually right here we have the inverse of the bit right here, since we have both what the value is. Since there's only two states, we have the inverse of it, and which is right here, and we have the actual value. So I'm just going to plug in the inverse instead of the normal value, just so that I don't have to invert the input. So yeah, cutting down on those double inversions. Only invert when you need to, guys. But yeah, so now this right here should actually be working like a normal random access memory cell, although a very bad one at that. I actually have a really good design for random access memory that I'm going to be showing off at the end of this series. But for the moment, let's just show that if we read something out right now, we have a... do we have a 0 saved? No, I mean a 1 saved. Yeah, I think I do. Anyways, so now it's off. So I'll just write that there. And, oh, so it does have to be on this side. Huh. Ignore that. This is the inverse right here. Sorry, I had a bit of derping about. So if we read right now, it's going to be off. So now, though, if we turn this on, and then we want to say we want to write to it now, then why isn't that flipping? Why isn't this torch turning on? Oh. You know what? Fine. That's what I'm going to do here. Because that's going to work just as well. So then that's just going to flip the latch like that. So, yeah. And in fact, I think I did have it right the first time. Yes, I did. What a derp I am. I was thinking straight, but because it hadn't actually saved the value, because I was completely derping out, yeah. But anyways, so now we can actually read it out. And so, yeah, and there should be redstone dust there. So now, if we sorry for all this derping about once again. Anyways, but if I read this, if I tell it to read it out, then we've just saved a 1 into it. So, yeah, it should give us a 1 back out. And if we turn this to a 0, and then we read it again, it's still saved as 1. But now if we were to save it as 0 again, like we have right here, and then we were to read it out, oh dear. Wait, please tell me that... Why isn't that getting powered, though? more importantly, derps. I'm full of the derps. There we go. So now it's actually written. Oh my gosh. What? What? What the heck? Did I have it right the... this is slowly deteriorating into me derping out. Anyways, I think I'm gonna... No, I'm determined to do this on camera. So, I think that all that means is that we got this wrong again. And it should be this end, right there. And I'm going to get really mad if this is wrong. So now we read it out, it should be 0. Now we're going to write a 1 again. Read it out. And it's not giving it a 1 because once... because it rewrote it because I powered it with a lever like that. Anyways, let's write the 1 again. Read out the 1. Yes, it's a 1. Good. Turn that off. It still has memorized the 1. Write the 0. Read the 0, and it's still memorizing the 0. Okay, great. This thing's working. I'm pretty fed up right now, given how long this has taken and how many times I've derped out right here. But, yeah. Hopefully I was able to get the purpose of random access memory across to you guys. So, yeah, was there anything else that I wanted to do? Let me just quick check my notes quickly. Yeah, that's basically it. And also, we would have potentially a whole bunch of these guys in a system like this, so that we can write to this, so that we couldn't just write to this this RAM cell right here. We could also write to another RAM cell, and then we would stack this outwards so that we would be writing to a whole bunch of cells at once and reading from a whole bunch of cells at once. And then we would stack this guy up upwards so that we can have multiple places that we can read and write from. But, yeah. So, it's easier to see when it's actually implemented. Once again, I'll be showing off a build that makes it really easy to see this and really, really, really nice build at the end of this series. So, yeah. I hope I haven't gone over my time limit. Bye-bye.